Mr. McBrien. This is SCH4U Reactions Part 2. So we need to be able to explain chemical reactions. We've already touched on a number of them yesterday. We're going to complete the list today so that we'll be able to talk about everything except polymerization. Okay, so we talked a little bit about alcohols yesterday. Today we're going to complete the process. So condensation is the way that we get ethers from two alcohol molecules. And essentially what we do is we react them together in the presence of sulfuric acid, and it kicks out one water molecule, hence the term condensation, and forms the ether based on that. So we can react two of the same chains together, or we can mix together one alcohol with a different alcohol in order to get an ether that's a derivative of both. And some of you can probably anticipate the challenges associated with that piece. So let's look at a reaction then. So here we've got what looks to me to be ethanol and a second ethanol molecule. And we will see that the sigma bonds connecting the hydrogen to the oxygen on the left-hand side and the sigma bond connecting oxygen to carbon on the right-hand side are broken, and we form a new bond between the carbon on the right and the alcohol on the left. And the result, we kick off a water molecule and we're left with diethyl ether. Okay, aldehydes and ketones. We saw yesterday that we can make aldehydes and ketones from alcohols. We can also reverse this process. So, if we apply heat pressure and a catalyst, we can form aldehydes from primary alcohols. We can also form ketones from secondary alcohols. So essentially all we're doing is we're adding hydrogen across this double bond. And what we're left with then is the alcohol. And that addition can also occur on the ketone as well. And all it does is form the secondary alcohol, of course. So one thing we can't quite see in this second molecule here is the fact that the second hydrogen that we see on the left-hand side is in fact added to this number 3 carbon. So it's explicit in the top, it's implicit, it's not shown on the bottom, but that hydrogen is there. Okay, alcohol undergoes an interesting reaction in the human body. So we haven't really talked too much about biological reactions in this course. We might as well talk about one now. So the liver is one of its primary functions in the human body is to get rid of toxins, including ethyl alcohol or ethanol. They do this by reacting with this ethyl alcohol to form acetaldehyde. And from there they further react it to get rid of it, to get it out of the body. It's interesting that it's that aldehyde that in fact impairs coordination and that is so characteristic, of course, of the consumption of alcohol. It's really that aldehyde that is toxic, not ethanol itself. Now, interesting is a breathalyzer test takes advantage of essentially that same process, but remember we talked about the idea that when you oxidize an aldehyde, it can go further to form a carboxylic acid. In fact, a breathalyzer test takes that one step further, taking that aldehyde and converting it to a carboxylic acid, which can then be quantified. Okay, so let's do a little check. I'd encourage you to pause the movie now and think about the reactions. So we're reacting propanol. We're reacting propanol now, and we have 3 sets of reaction conditions as well as 3 expected products. And I encourage you to stop, pause the movie, and think about which sets of conditions can produce which product. Okay, welcome back. So hopefully you got the right answer. If we take conditions A, acid and heat, we can kick off that water molecule and form the alkene. So this would be propene. If we use oxidation conditions, gentle oxidation conditions, we can kick off the hydrogen from that molecule, oxidizing and getting the aldehyde. So number B is associated with the with propanol, number 3. And finally, of course, reacting with oxygen gives us our combustion products. Okay, we can also form esters. We already discussed how these are produced. We react an acid with an alcohol, and this reaction should look very familiar. It's not unlike our production of ethers. So we break the bond between the oxygen and the carbon, break the bond between the proton and the oxygen, kick off water, and form our ester. This is done in the presence of acid. And again, if we want this reaction to proceed to completion, we can do something like pull out the water as it is produced. The reaction to create amides is essentially identical. The only difference is that we're going to have an amine on the left-hand side, and the exact same reaction applies in the same product. It's just we have a nitrogen in here instead of an oxygen. So creating amines, on the other hand, is a little more complicated. So primary amines are pretty straightforward. We can react with ammonia, take the alkyl halide, and we'll kick off hydrochloric acid and produce our primary amine. If we want a secondary amine, what we can do is react that alkyl halide the same way, but react it with a primary amine. So in essence, it's the same reaction when you think about it. Again, we kick off hydrochloric acid, but in this case, we wind up with the secondary amine. All right, so go ahead, please, and read over the lesson note. Make sure you understand everything we've covered today, and then go ahead and finish up the today's worksheet. Thank you very much. Have a great night.